Okay, so it's 5 o'clock. I'm going to start the presentation. Hello, my name is Ryan Johnson. I'm from CryptoWire and George Mason University, and I also collaborated with Angelo Stavro from CryptoWire for this research. And today we're going to talk about the read logs permission on Samsung devices and how to get it back. So here's the agenda for today. We're going to talk about the read logs permission, what it is and what it does. We're also going to talk about the sensitive data that's written to the Android log. We're going to talk about how to regain the functional equivalent of the read logs permission on Samsung devices. I'm also going to talk about why the text of notifications is written to the Android log on certain Samsung builds, and also talk about how to fix it. So the Android log, it's mostly used for debugging. So in your application, when you reach certain states or an unexpected event occurs, generally you would want to write something to the log. The crash dumps also go to the log, so a developer can get this feedback and improve the program. So any process on the Android operating system can write to the Android log. And if you've written a program other than Hello World application for Android, you've probably used the Android log. You use it using the standard Android API. It's Android util.log for the main log, slog for the system log, an event log for the event log. And also if you use certain log tags, it will go into the radio log. Generally, you read it with logcat, which will look at the log buffers and translate them from binary to plain text format because it's easier to work with. And on current Android builds, you need your application, when it's installed, it gets a user ID and it gets assigned groups depending on the permission. And you will need to be part of the log group to actually get full access to the Android log. And Google applications, user apps, any third-party applications, as well as the Android operating system itself can write sensitive data to the Android log. So the read logs permission gives you access to these device logs. On Android 4.1 and below, you could just request the read logs permission, and this would be granted to any application, and you would be able to read the log messages system-wide from any process on the operating system. On Android 4.1 and up, this permission was no longer granted to user applications. On the left is a snippet from the Android manifest.xml from the Android package, and this is actually where the read logs permission is declared. So at the top, you can see an XML comment saying why they took it away. It's essentially because it can contain private data. The red text below that is actually where the read logs permission is declared. And further below that shows the protection level of this permission, which is system, signature, or development. So you either need to be signed with, your application needs to be signed with a platform key, or it needs to be a system app. It needs to be installed on the system partition, or it's also a development permission. So a user can explicitly grant this permission to an application using ADB shell PM grant package name, and then the permission, which is read logs. So why try to regain the read logs permission? It's for the same reason they took it away. It's for the private data. So these are just some of the items that I've noticed showing up in the Android log. There's the user's email address. There's the cell tower ID. And each of these log entries has a timestamp, so you can kind of track the user, see what they're doing at certain times. So the cell tower ID, once you have the cell tower ID, you can access a free and open database to see exactly the latitude and longitude of that cell tower, and kind of if the user is moving, you can see the different cell towers that they're connecting to when they're doing the handoff between base stations. There's also raw GPS data from the satellites. You can further process this and get the exact coordinates of the user. There's also non-Google account username, so I've seen Twitter show up, so you can get the user's Twitter profile, start looking at pictures and get information about them depending on their privacy settings, their cellular network and Wi-Fi information, so you can get the private IP address on the carrier, the private IP address on the wireless network, the SSID, routing information, the DNS gateway, and the default gateway. There's also the voicemail number that shows up. So once you have the voicemail number, you could try a guessing attack on their PIN, as well as a brute force attack, depending on the security settings of the voicemail. I also saw my full name that was associated with one of my Gmail accounts show up in the log. The Google ID show up in the log, so you can take this Google ID, put it into Google Plus, and start looking at their profile. Depending on their privacy settings, you might see their picture or anything they share publicly. You can also tell when the user is present or not. There's a broadcast intent, action user present, which is sent when the user is active, so you can tell when they're not present. So then if you're doing some attack, you might want to wait till they're not present just in case there's any side effects. There's also various IDs which are associated with the PIN or the SIM card, which is the ICC ID, the IMSI, the MCC MNC, so you can see the country they're in as well as their carrier, the device serial number, and the MAC address. So these are some unique IDs you could use to track the user. And also when you send an intent from one application to another, this shows up in the Android log. You can also embed a URI into the intent, and this will show up in the log as well. So say if you're using Google search, and then you search something, you click on it, it will send an intent to the browser with that URI. So you can see what the user is searching for and looking at. Also, when you're using Chrome, anytime there's any errors, this could be just due to connectivity issues. These URLs for which there are errors will show up in the Android log. You can also tell which applications and processes are executing on the system and when, because Activity Manager provides all of this data. So here we have on the left a screenshot showing various notifications. I've chosen to highlight a text message that was received. And over on the right is a log entry from a dump state file. And the text in red on the top is the log tag, which is notification enqueue. The next red text is com.android.mms, which is the application which sent this notification. Below that is the text of the notification that the user sees. So you can see it's from the number 224444, and you can also see the verification code, which is 546729. So using this, if you have an app on the user's device, you're reading the logs, you get their Gmail account, which shows up in the log, then you send a password reset, and then elect to receive it via text message, and then you can essentially lock them out of their account, or their Gmail account, and then lock them out of other accounts where they use the Gmail account as a recovery email, so you can start taking over some of their accounts. And this is a method to bypass two-factor authentication. So any application or process can write any arbitrary data to the log. So I've chosen to highlight an unnamed fitness and health application that's on Google Play. It writes everything possible to the log. It's fairly popular. It's got 5 to 10 million installations. According to Google Play, 85,000 reviews. And I also told the company of the behavior of writing all the sensitive data to the log. So here we actually have the log messages. I've redacted some of the items so the app isn't identified, but there's the user login. So there's the Gmail account that I used to create the account for the application. There's also the password I used. There's also the cookie, which using the cookie, as long as it wasn't expired, you could log in without the username and login, but that's not necessary since they also give you the username and password. So here are some more items that are written to the log. There's a security token, which could be used for OAuth. And in the application, you can input any medical procedures you've undergone, as well as any medications that you're taking. So whenever you enter them into the application, it will immediately write them to the Android log. So I've just entered some phony data in here. And this is medical information, so it's generally regarded as highly sensitive. You can also put any conditions you have in the Android log. So I just entered some phony data here. You can also input insurance information. So I just used a phony Aetna account and put in the member ID and group number. And then this also showed up in the Android log. So regaining Android log access. So I've identified 3 conditions which will trigger a world readable log file to be generated on Samsung builds of Android. So if there's an uncaught exception in the AppStalvik bytecode, so your application is executing and there's some uncaught runtime exception, this will force close the app and then also generate the world readable log file. There's an application not responding event or an ANR event. If the application is not responsive to the user and it's doing too much work on its UI thread and not responding to UI events, then it'll be an ANR event. And this will also generate a world readable log file. The last is if your application has a native code library and some sort of error is encountered in the native code library, this will also generate a world readable log file. And the first 2 will actually generate a system message indicating the user that something has happened. And the third one will not if done properly. So here we have pictures of the three events. On the left is the uncaught exception, which essentially force closes the application and displays the system message to the user. The picture in the middle is the ANR event, which it will prompt the user whether they want to wait for the application to become responsive for some period of time or if they just want to kill the application. And the third is the native code error, which in this, when done properly, won't generate any message and will go on to display or perform whatever functionality it was intended to, which in this case, it was just to display an image view. So the dump state binary is responsible for writing the world readable log files. So dump state is run anytime there's some sort of error or like unexpected condition in the application. It can't be run by user applications. You need to either be the shell user or belong to the log group to actually, or be the root user to successfully get the output from dump state. So the dump state file, it's usually 3 to 6 megabytes. It contains the Android log, the kernel log, system properties, as well as a lot of data from the proc file system. And below is the actual path to the binary. So the error in native code, what you would do is you would have an application, you would integrate a native code library into this application. So then from the Java layer or Dalvik, you would use the Java native interface or JNI to call into a C function. So once you're in the C function, you're outside of the Dalvik virtual machine, you want to fork the process, which essentially clones the process. In the child process, you want to call abort. And in the parent process, you essentially just want to return from the function back into the Dalvik virtual machine. And when the child process calls abort, it's going to, the abort function, it's going to send the sigabort signal, which is going to get handled by debugger D, which debugger D runs as root, and this is going to call dump state, and it has the permission to do so, or the privileges, since it's running as root. And debugger D, it injects, or it sets the default signal handlers into processes in Android. So once sigabort, it injects that signal handler, so it will get called once the sigabort signal is sent. And on Samsung devices, there's the actual path to the dump state file when you create an error in native code. It's /data/log dump state app native text.gzip. And if you do it properly, if you fork the process and do this, it won't generate any error message. But if you don't fork the process, it will generate an error message and crash the application. So here is a partial listing of files in the /data/log directory. There's the 3 dump state files that correspond to the 3 conditions that I mentioned previously. And the thing to pay attention to are the highlighted R's in red, which on the file permissions, which show that these files are publicly readable by any user on the device. So any application on the device can read these files. And below is the actual command that's being executed by debugger D to generate the dump state file. So the /data/log directory, this is not in standard AOSP. It was created by Samsung. So I pulled the init.rc file off a Samsung Android 4.4.2 build. And the init.rc is a script that runs after boot to perform certain commands and start services. So here, the actual snippet from the init.rc file shows that they're creating the /data/log directory, changing the owner of it, and then changing the file permissions. So the dump state file, I've provided a snippet here, and it contains a date and timestamp, the process ID that wrote the log message, the parent process ID, the log level, the log tag, and the log message. So here I've highlighted a log entry. In red, the first one is notification enqueue, which is the log tag, which the notifications are getting written to the log. The next is the package name of the application that wrote the log message. In this instance, it's com.whatsapp, which is the package name for WhatsApp on Android. And the rest of the red text is the actual text of the notification. So this is just a message that says test message for the Android log with a smiley face, and it's from a user on WhatsApp named Nikos. So how to exploit this? You would need to create an application, and you would request the receive boot completed permission. So once the boot sequence completes, the Android OS will send out a broadcast intent to applications that have the permission to receive it. So once the receive boot completed is received in a broadcast receiver, you would, from the broadcast receiver, start a service and have that service schedule a thread to run at whatever interval you want. And then that would call that C function, which forks the process and calls sigabort. So you could do this in the background, even when the user isn't using the application, and this could be done whenever you want. So once you force the generation of the dump state file, then you can unzip it just using the Android API. From there, you could, if you know what you're looking for, you could use regular expressions to get any data that you know is already known. If not, you could just exfiltrate the whole file and process it later. And the only evidence of this happening is some log messages. So if the user is using ADB and recording it, they would be able to see this, but ADB is generally for developers, and most users probably wouldn't use it. So here we have the same screenshot as before, showing the different notifications. There's also, I've highlighted the Facebook Messenger application, which is a very popular Android application that many users have. Again, up at the top, there's the notification enqueue log tag, which is the log tag which notifications are getting written with. The package name, which is com.facebook.orca, which corresponds to the package name for Facebook Messenger on Android. And below is the actual text of the notification corresponding to the highlighted notification on the left in the screenshot. And it's from a phony Facebook account, the name of Elena Boatner, and it says, this will show up in the Android log with a smiley face. So once I saw that it was happening, I wanted to see why it was happening. So off my phone, I pulled the framework.odex from the device, used backsmally to generate the smally files for it. And the android.app.notification class is what you would use when you are creating a notification. So I looked at the toString method of this class, and the toString is if you want a string representation of the state of an object. So I looked at, compared Samsung's implementation for the notification class as well as AOSP, and I noticed that Samsung was including various string instance variables in the output of the toString, whereas the AOSP was not including them, specifically their content title, content text, and ticker text. And these are actually what the user sees when they look at a notification. So here I have two different builds, both 4.4.2, a Samsung build and an AOSP build. And this is the same notification, the toString of the notification. So at the top you see AOSP, it's much more terse. And if you look at Samsung, it's more verbose. And the text in red is the actual three instance variables that I mentioned previously were in the toString: content title, content text, and ticker text. So there's the notification manager server, which runs in the system server process. So when you are interacting with the notification manager using the front end API, you're actually calling an interface, which is going to interact with the notification manager server on the back end in the system server process. That shows at the top, it's com.android.server.notification manager service. And I looked at the source code for this. There's the enqueue notification internal method, and I provided a snippet of the source code of this method. And it essentially says, and this is called whenever a notification is received, and it essentially says, the source code, if the notification isn't from the download manager, get the toString of the notification that's being sent, as well as a few other data items, and then it's being written to the event log, which goes into the Android log. And it's also under the notification enqueue log tag. In this call, it's actually an integer, but it gets converted to the string of notification enqueue. So vulnerable builds. We essentially tested a bunch of devices that we were able to get our hands on from friends and colleagues. We also downloaded stock Samsung firmwares from the site Sam Mobile. So if you have a Samsung device, you can just, assuming you're downloading it for the correct model, you can download a stock ROM from there, put your phone into downloader or Odin mode, and then flash it to your device using Odin. And the vulnerability where the text of notifications, it's only in certain builds from Android 4.1.2, Android 4.3, and Android 4.4.2, and it got fixed in Android 4.4.4, and it's not present in Android Lollipop. So here is a screenshot from the Android developers website, which shows the current Android platform usage. And this is just data, I believe, for a 7-week period ending March 2nd. And this is just from the devices that have checked into Google servers. As you can see, the largest component is Jelly Bean, and the next largest component is KitKat. And both of these are it doesn't break down KitKat by the minor version number, but KitKat and Jelly Bean both contain the vulnerable builds, at least on Samsung devices, at least a slice of them. So threat mitigation. So if you are running vulnerable Samsung builds, you would want to update the OS if possible, if your model is supported for an update. If not, you can actually use ADB once to prevent the dump state files from being world readable. So you would use Android debug bridge, and you need to change the file permissions on the dump state files. So these files have the owner of shell as well as the group of log, which is the same as ADB. And dump state, when it initially runs, it does have root privileges, but it drops them to shell user, and it belongs to the log group as well as some other groups. So the first thing you would want to do is you would want to delete any existing dump state files. Then you would want to change directory to the /data/log directory. Then you would use the touch command to generate an empty file or empty temp file for dump state app native, because it writes to a temp file first, and then it moves it to not a temp file. So once you generate the temp file, you want to change the file permissions to 000. So no user on the device can read, write, or execute the file other than root, but dump state isn't executing as root when it's writing these files. So once then one of those 3 conditions occur, it's going to try and write to one of these files, but it doesn't delete it first. It just uses output redirection to overwrite the file. But since it doesn't have the correct file permissions to write to this file, it's just going to silently fail and not write the log data, just due to the restrictive file permission. So the conclusion, a secure programming practice, is to sanitize any log data before writing it to the Android log or any log, because other users may have access to that. In Android, they took it away, but I found a way to get it back on Samsung builds. You also need to, when you fork AOSP or Android open source project source code, if you're making your own build, you need to be careful about what you're adding in there, because you may introduce vulnerabilities. So you need to test and audit it carefully. And you also need to be careful of the file permissions set on files that contain sensitive data. In this instance, there was world readable log files that contained private user data. And I also informed Samsung of this, and as of Android Lollipop, these files are no longer world readable. Thank you for attending the presentation. Are there any questions? You could use it without it, but if you didn't have the receive boot completed permission, you would only be able to generate that dump state file only when the user is using your application. So you could do it without it, but yeah, once the application receives the receive boot completed in broadcast intent in a broadcast receiver, and then it starts a service, which then is going to run in the background or have persistent execution. And then at whatever interval you want, then you can use JNI to call into the C function, and then fork the process, call SIGABORT in the child process, parent process returns. And then from there, the world readable dump state file is created, and then you can just process it. You can only, if you don't have that, you're going to need to wait until the application starts the app or launches your main activity before. Okay, you're welcome. Yeah. So on 4.4.4, that's when they fixed writing the notifications to the log. You can still generate the dump state files, but once after I informed them on Samsung or Android 5, they've made those files not world readable. Yeah, they just changed the permission, so it's the same except they took away that R or that last R on the file permissions to make it world readable. Yeah, well, if it's a rooted phone, it can, in the application that's requesting it, depending on how they're doing it, if it's Super SU and the user grants it, once they do that, then, that process can do anything on the device. Are there any other questions? Yeah. I haven't checked all phones. I just checked what I had. I checked a Nexus 5. It doesn't have the /data/log directory, and when there is a crash, generally I think it gets written to /data/data com.android.shell, which is only readable by the shell process. So if you're using ADB, those crash dumps go there. So those are much more well protected. So you won't, unless you're the shell user using ADB, you won't have read access to them. But I haven't checked every single manufacturer to see if they've made any world readable log files. Or maybe there's another vulnerability. I haven't checked all the vendors to see how well the crash dumps are protected. Not right now. I need to get access to a lot of devices, which I think would be kind of tough, or not too tough, but not at the moment. But there may be other vulnerabilities out there in other manufacturers, at least in regard to the logs. I'm not sure about it. So. Any other questions? Okay, if there's no other questions, thank you for coming to the presentation.